Good afternoon, class. And here's elementary statistics practice test number 1, covering module 1, chapters 1, 2, 3. Here's chapter 2, exploring data with tables and graphs. I want to remind you of a pledge. In short, I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam. That's the bottom line. You could use formula sheet tables and a graphing calculator. All right. Given the frequency distribution table, short FDT, answer the following questions. The number of classes in the table is. So first, what is a frequency distribution table? A frequency distribution table is a statistical tool used to organize and summarize raw data. It breaks down a dataset into distinct categories or intervals called classes and shows the exact count frequency of data points that fall into each group. So here's one group, for example, from 11 to 20, how many? We have 5. From 21 to 30, we have 6. So 1, 2, 3, 4, 5. That's the number of groups. 5 is the number of statistical age group defined. So I hope that's clear too. The class width. So in each class, we want to know how many. Normally, the class width is chosen such that they are identical for each group. In some instances, they may not be. So how do we calculate that? The width is upper limit minus lower limit plus 1 unit. I want to make a point here. This column, lower limit. So the lower limit of the first class, 11. Second class, 21. Third class, 31, so on and so forth. The upper limit of the first class, 20. The upper limit of the second class, 30. The upper limit of the third class, 40, and so on. So upper limit, just pick any group and say, for example, the first group, 20 minus 11 plus 1. And that one is 1 unit because a unit may refer to a number such as 0.1 or 10,000. So 20 minus 11 plus 1, that becomes 10. Also, so upper limit minus lower limit plus 1 unit, or difference of 2 consecutive lower limits or upper limits. For example, if I pick those two, okay, 21 and 11. If I pick those two, 50 minus 40. Pick those two, 51 minus 41. That's what we mean with the second method. And that might be easier. Nevertheless, I hope everybody is clear on that. The midpoint of the fourth class. Let me erase my work. So basically, you add up the limits. Again, lower, upper. Add up, divide by 2. For the fourth class, here's the fourth class. You want to add these two numbers, divide by 2. The lower limit is 41. The upper limit is 50. They add up to 91 divided by 2 is 45.5. The lower boundary of the fifth class. So here's the fifth class. Okay, this is the lower limit. We want the lower boundary. The way the boundaries work is as follows. We go with the upper limit of the previous group and the lower limit of the current one, add them up, divide by 2. So it's 50 plus 51 divided by 2 is 50.5. 50 plus 51 divided by 2. Midpoint of the upper limit of fourth class and the lower limit of the fifth class. This will be the boundary, the upper boundary of the fourth class as well as the lower boundary of the fifth class. Limits, we've already discussed that for the first class, lower limit, upper limit. So therefore, 20 is the upper limit. So upper limit is 20, first class is it goes from 11 to 20. Sample size, basically you add up the frequencies n summation of x, this is called x5, 6, 9, 11, and 4, we add them up, and N is summation of X. I hope you remember sigma. Uppercase represents the sum. And as I mentioned, we add them up, 35. That would be the sample size. We're going to continue with the same question. First, okay, let's find all the midpoints and boundaries. Let's go with the midpoints. Remember what we do. For example, here, we said 11 plus 20. 11 plus 20 divided by 2. 15.5. Now, we can do the same thing for the rest of it. However, we know the width is 10. So one easy way, just add the width. That is the faster way. So one more time. I can say 21 plus 30, 51, divide by 2, and I get 25.5. Or simply put, because I already have the width, I'm going to add the width. So the next one is 25.5. The next one is 35.5, 45.5, 55.5. Very easy. We can find all the midpoints. Now, what about the boundaries? Again, reminding you, if I want the boundary here, so I'm going to put these two together, find their midpoint, and the midpoint 20 and 21 divided by 2 is 20.5. This will be the upper boundary of the first and lower boundary of the second class. Then what do? We can do the same thing with the rest of them, but again, we're going to go back to the class width and make it easy. All you have to do, add 10 here becomes 30.5. Okay, just to give you an idea. So I'm going to add 10, and I get 30.5. And I'm going to write exactly the same thing here. What about here? I'm going to add 10, I get 40.5, and I continue. What about this one? I'm going to say 20.5 minus 10. That makes it 10.5. So the lower boundary of the first class, I'm going to subtract the width from the upper boundary, and I get 10.5. Okay, so I'm going to erase my work so it becomes clear what we are dealing with. The next one is asking for RF, relative frequency, and relative frequency by definition is frequency divided by N. Okay, so for example, for the first class, the frequency is 5. We already have the N, otherwise we have to calculate it. It's 5 over 35, or simply 1 over 7. Now, they may ask for relative frequency or percent frequency. Then you go with 14.29%, depending upon how they want it. So this is 1 over 7. Always go with a precise answer. If they don't give you how many decimals, you have to go with the precise answer. What about this one? 6 over 35, 9 over 35, 11 over 35, 4 over 35. So those are the ones, very straightforward, everybody. Find the model class and the mode. I hope you remember the mode is the one with the highest frequency of occurrence. The same thing here. The model class is the one with the largest frequency. So you look at this column and you see that which one is the largest, clearly number 11. So class number 4 from 41 to 50 with largest frequency of 11. So that's the model class, everybody. What is the mode? It's midpoint. The mode is the midpoint of that class, which is 45.5. The following frequency table describes the speed of drivers ticketed through a 30 miles per hour speed zone. Calculate the relative frequencies for all classes. So we have this. And from here, we want to find the relative frequencies. As you know, RF is F over N. So first thing first, we have to calculate the N. That means N is summation of X. Add those numbers. and we get 50. 25 plus 14 plus 7. So you add them up, okay? Add them up. And so if that is the case, so we put a column next to this one, corresponding to the first one, 25 over 50, or 1/2. The second one, 14 over 50, or 7 over 25. The next one is 7 over 50, 3 over 50, 1 over 50. What percentage represents the speed of 53 miles per hour? So you look up and you find 53 here. So that means, in essence, those numbers. So cumulative frequency distribution of 53 miles per hour or less refer to the first three classes. So when you look at the first three classes, what do we have here? 1/2, 7 over 25, 7 over 50, 3 over 50, 3 over 50, 7 over 50, and we're done. Those three. We want to add them up. So 25 over 50 is 0.5, 14 over 50 is 0.28, 7 over 50, 0.14. They add up to 0.92 or 92%. The other way is that we can, let me erase my work again. We can do this. We can add those and divide by n. We get 46 over 50 or 92%. What about the boundaries? Well, reminding everyone, boundaries are the midpoint between the upper limit of one class and the lower limit of the next class. So for example, these two, they result in 45 plus 46 divided by 2, or 45.5, which is the upper limit of the first, lower limit of the second class. Now, we can calculate for the rest of them, but the faster and easier way is to find the width. So as you can see, the width is 4. Why is that? 45 minus 42 plus 1, or just pick any of those two. 61 minus 57. 54 minus 50. That's how you get the width of 4. So having said that, all you have to do, add 4, you get 49.5 here. Same thing here, 49.5. Then you add 4, 53.5. You do the same thing for the rest. Over here, you subtract 4. You get 41.5. This is how you get all your boundaries. We're going to continue with the same question, and we want to construct a histogram corresponding to the frequency distribution table. Okay. Histogram, this is the information from the previous page. Over here, you can put the midpoints, you can put the limits, or you can put the boundaries. Normally, we put the boundaries because for OJI, we need that too. So reminding you, these are the boundaries. And so we're going to put them here. And then the largest number is 25. We put from 0 to 30, some sort of a decent scale. So, for example, this one is from 41.5 to 45.5, 25. So this is about 25 here. And the next one is 14, about here. So the next group, so on and so forth. This is how it looks like. Okay. Also, I want to mention something else that comes up from time to time when it comes to your assignments. Finding the width from the histogram. If limits are given, normally boundaries are given. But by any chance, if limits are given, the width is calculated as follows. We do not add 1 as explained before. Upper limit minus lower limit. That's which is really the proper way would be upper boundary. B stands for the boundary minus lower boundary, but not the limits. But if you are just given the histogram, that's the way to go. So we are looking at the same question. Okay. Now we want to find what? Prepare the cumulative frequency distribution table, a cumulative relative frequency distribution as well. This is it. And we have the n because it's always important to have it. So what do we find? We have to go with always the very first limit for the lower limit. And in this case, the upper limit is 45. And as you recall, the upper boundary for the first class was 45.5. So cumulative speed. So we are looking at this one. And by the way, you always look at if this is frequency or relative frequency. There are two different things. So from 42 to 45 or less than 45.5, you don't use both. But so what happens here, if you go this route, the upper limits remain the same. So the upper limits are 49, 53, 57, 61. The lower limit will always be 42. Why? Just look at this and the meaning of that. Because of this, the lower limit remains as 42. Okay. But what about the upper limits? The upper limits are exactly what we have here. What about the boundaries? You just write the upper boundaries. So this is how it looks like. I'm going to erase my work. So again, when you have a cumulative frequency, the lower limit will be the lower limit of the first class for each and every class. The upper limits, they remain unchanged. The boundaries will be the upper boundaries, which means everything from 42 to 45 belongs to this group, or everything up to and less than 45.5. But 45.5 itself belongs to the next group. So what about the relative frequency? We're going to write number 25 here. So what happens, because this is from 42 to 49, that's the meaning of it. So you have to add this to 25 and 14, you put it here. Over here, you get 25 plus 14 plus 7. Over here, you get 25 plus 14 plus 7 plus 3, and the final one plus 1. So the last one must always be equal to n or x. Otherwise, we've made a mistake. Okay? And so that's the way we go with cumulative frequency. Now, what about the relative frequency or percent frequency? Again, we're going to repeat the first one is 25 over 50. Everybody remembers that, or 50%. But what happens to the next one is 39 over 50, 46 over 50, 49 over 50. And the last one must always be 1 or 100%. Otherwise, we've made a mistake. And that is extremely important to understand. We're going to continue, and we want to draw an ogive of what? Cumulative percentage. You want to pay attention to this. They ask you for frequency or percentage of relative frequency. So again, from the previous page, we have this one, we have this one. Everybody remembers that. So always use boundaries in the case of ogive. And of course, over here, if you were to put the frequencies, maybe maximum you would use 50 or 60. But this is a percentage. So you have to go to 100 or a little bit more than that, 100%. Okay. Now, the way this thing works, the lower boundary of the first class always corresponds to 0. And the upper boundary of the last class corresponds to 100%. So this should be either 1 or 100%. And if it's just the frequency, then it would be 50 if it were frequency. Then the next one, this is 50%. So the upper limit of the first class corresponds to 50%. And you connect them with the line segment. This is a line. This is not a curve, everybody. 78% for 49.5. So somewhere there. Again, a line segment, and you continue all the way to the end, looking like that. I'm going to erase my work. So each piece is a line segment. It's not a curve. So what is it good for? Okay, a question like this. Using the OGI 5, the percentage of drivers who drove 47 miles per hour or less. So let's see how we deal with that. So having said that, along the horizontal axis, you locate 47. Okay, and now that is your answer. That's how you come up with the answer. So number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%. Therefore, 60% maybe to 61% of drivers drove 47 miles per hour or less. So pretty straightforward, everybody. Given the following sample, the ages of 40 tenured faculty at CSULB, n equals 40 ages, construct a dot plot, construct a stem plot. So let's start with the first one. What is a dot plot? A dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values or categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as a stack of dots, and that's the key, okay, as a stack of dots. So that's how it works. Okay. Let's see how we are going to deal with this. All right, so to construct the dot plot, first and foremost, we must rank the data, and we're going to go from smallest to largest. When we rank it, goes from 32 to 63. So the very first step is to rank it. Now we're going to go with some sort of a number line. And we are going to put ages, and again, this is sorted as mentioned. And you start from a number smaller than that, and you go to a number larger than that. So this is a scale from 20 to 70, 20, 25, 30, 35, and so on. So we start with the first one, and we locate it somewhere here. We put a dot, okay. 37, somewhere here we put a dot. We're going to do the same thing with 39. 40, 42 we located, we put a dot. Same thing with 43, 45 and 46, 45 and 46. We put the 47, and we notice there are two of them. So we're going to put 1 just at top of that. And that's the idea. If you get that, you can figure out the rest of it. So if we go from 32 to 46, we only need 1 dot for each spot. When we hit 47, we need 2. We continue and we notice, for example, for 53, we need 1, 2, 3. So that's exactly what we come up with the answer, looking like that. 1 dot for each one. So when a number repeats, you just stack up the dots. That's all. What does it indicate? Clearly, the ages range from 32 to 63 years. Also, there is more tenured faculty at older age. Look at the number of dots. Then we have more here. That's what it tells us. All right, so we are going to move on. So the second part was stem and leaf. And what about that? Let's quickly look at its definition. Stem plots, also known as stem and leaf plot, display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value digits to the left and one leaf to the right. We can see the distribution of data while keeping the original data values. So that's the definition. Now, to do this, we are going to rank it again. Since we've already done that, we're going to use the same ranked data. Okay, so you have to sort it first and foremost. That's important to remember that. So we're going to use the same thing. And again, it's going to go from 32 to 63. So we're going to start with the numbers, the tens digits are 3, 4, 5, and they end up with 6. So 3, 4, 5, 6. So for 3, we have only those 3 numbers. So we are going to put now the ones digits. So we're going to put 2, 7, 9. So if somebody was to read this, would read 32, 37, 39. Now, what about the 4s? We have so many. So we are going to put 0, 2, 3, 5, 6, 7. We have to put 2 of them. 7, 7, 8, 9. See, we have 2 of them. So if somebody was to read this, would read 40, 42, 43, 45, 46, 47, 47, 48, 49. So very straightforward. Now for the 5, we're going to put 0, 1, 1, 2, 3, 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 8, 8, 8, 9, 9, 9. So many of them. And again, just for the sake of argument, the last one is 9, and you have 3 of those. You can't put just 1. That's not acceptable. And what about 6, 0, 0, 1, 1, 2, 3, 3? We put them. Okay. And again, the ages range from 32 to 63. So you can even read it. Okay. If you don't have this one, this is the smallest number, everybody. This is the smallest number. And this one with this one, 63, is the largest number. Okay. You should be able to get it from this. And having said that, again, the age range from 32 to 63 years. Also, there is more tenured faculty at older ages. So notice 5 and 6 are larger than 3 and 4. So you have more of them at tenured faculty at older ages.